Hello, Flat Earth researchers, debaters and debunkers. While I was filming the sun setting off the west coast of Phuket the other day, I noticed this rather distinct arrangement of sunspots. And it turns out that someone in the UK also filmed the same sunspots at around the same local time on the same day. So I thought it was an excellent opportunity to compare how the orientation of the sun appears differently depending on where you are watching it from, because the sunspots and this arrangement can show us the kind of orientation that the sun appears to each of us. So on the left there is a frame from the footage taken by Keith Truther from England. I'm not sure exactly where, but at around 5 p.m. or 1700 local time on the 24th of March. And on the right we have how I saw the sun from Phuket at around 1800, just before it set. So you can see that the arrangement of the sunspots is slightly different for each one. So let's examine that a little bit more closely. So let's compare how this arrangement of sunspots appeared for viewers in two different locations at around the same local time. I've taken frames from each of the pieces of footage and put them into GIMP so that we can more easily compare the two, starting with this one seen from Phuket just before sunset, and we see this arrangement of sunspots that makes a kind of square. So we have three individual sunspots making up three corners of the square, and the lower left corner is a cluster of sunspots as seen from our point of view just before the sun sets from Phuket. When we compare that to what was seen at around the same local time from the UK, we see that the cluster of sunspots now appears on the bottom right of the image. So in both cases, the observer is facing pretty much west at around the same local time, although the observations were taken maybe 5, 6 or 7 hours apart in real time. Local time is about the same. And so what we have is this apparent rotation of the sun of about 90 degrees from where it appeared in Phuket to where it appeared the same local time in the UK. I can show this by just going ahead and rotating this clockwise by about 90 degrees, and then we get a similar arrangement with the cluster of sunspots on the bottom left as it was when we saw it from Phuket. Okay, so this rotation or apparent rotation that we see when we observe sunspots on the sun is only seen where the north or south of the equator. If I watch sunspots from morning until night, I see them stay in the same apparent place until midday when the sun goes overhead, and then everything flips 180 degrees and whatever was on the top is now on the bottom. But in this case, what we do see when you're observing the sun from dawn till dusk in the UK is this apparent rotation. So if we just take this back, way back to 180 degrees from the original, this would then take us to how the view of the sun would appear from the UK for someone watching the sun on the 24th of March very early in the morning. It might be at a point when the sun isn't quite in view yet, but what they will see throughout the day if they watched the sun and followed its course as it arced across the sky from the south or from the east or the southeast to the southwest and west, they would see the sun appear to rotate just like this. So now it's getting on towards evening, and as the sun sets or goes towards the west, we would then see it has taken this rotational path to this point here. Now, these observations fit perfectly well with the idea that we're on a level Earth watching a small local sun orbit above the Earth between the tropics or above the equator. And so I've taken this heliareal boreal triaxial projection and put the locations and where the sun appeared at those observation times. Now, it really doesn't matter what kind of projection you use. This is not a flat Earth map per se. and it's not something that's taken from a globe Earth map, as it were, because there are no maps that tell you whether the Earth is concave or convex or level. Everything is mapped out on a level surface, and it can be projected in all manner of ways. This has an azimuth or a center point that is on the same North Pole as the Northern Hemisphere for what is assumed to be a globe map. Nothing changes about what we see happening in the sky or on the Earth just because a map is projected in a certain way. So the difference between a map like this and a map that would have you believe we live on a globe is just that a globe map is two azimuth points that represent two hemispheres, and then they are put together. So you have a North Pole and a South Pole, but this is just a projection from a singular pole. It's still the North Pole. So any distortion is going to be relative to this coordinate system that was already created to have us map out the Earth and the land masses that we know of so far. So it doesn't matter what kind of projection you use, but this is handy to give us an idea of an objective view of those two subjective observations from the ground. So we can see here that as the sun set in the UK, we had the sunspots in this arrangement here with the cluster of sunspots on the bottom right. And so that fits fine. If we just kind of move the sun as it would have moved across the sky, for observers in the UK, it would have been a southerly looking direction towards the east, the west eventually. It wouldn't go overhead like it does for me in Phuket. And eventually we get basically the sun and the arrangement of the sunspots appearing in the same way, just by moving the sun like this, okay? So let's just take the sun back along its path to where it might have been observed at about a 180-degree angle from the UK. And we can see here that for an observer in the UK, the cluster of sunspots would have appeared at the top left of that arrangement. And if you remember when we looked at that on this one and we went back 180 degrees, let me just do that now, we had that cluster of sunspots on the top left, okay? So as I said, this would be the view of the sun as seen from the UK early in the morning, possibly sunrise or maybe even before, but obviously you wouldn't be able to see the sun yet then. So cluster of sunspots on the top left, rotating as it arcs across the sky throughout the day until setting in this configuration with the sunspots on the bottom right. So in the morning, that cluster of sunspots would have been on the top left for that observer. And we can see that with the sun over here now, that view, if we extended that blue line to the sun here, we would see that from the observer's perspective in the UK, that cluster of sunspots would indeed be on the top left for that person's view. Okay, so this is a great illustration to show that nothing changes about what anyone sees happening in the sky. But if you want to use the sky to talk about the shape of the Earth and models to assume whether the sun is massive and distant or close and small, then you can make it fit any way you like. And it fits perfectly with what we observe in reality when we assume the sun is small and local. And we have this objective view, top-down view. It still fits with the subjective views that we experience. Okay, so when viewed from Phuket, the sun doesn't appear to rotate. I've got this, obviously it's going to come round on this particular projection like this, okay, but I don't see any apparent rotation of any sunspots when they're on the sun. I just see this flip, okay, as it goes overhead. But for someone looking further north from the equator, they will see apparent rotation Okay, the sun isn't actually rotating, it's just its apparent rotation because of the local observation. Yeah, and it works fine on a flat Earth, as you can see. Thank you very much.